Hello guys, hope you are all doing extremely well. In this video, I'm going to explain this problem non-repeating numbers. It is problem of the day from Geeks for Geeks. Let's get started. Given an array A containing 2 into n plus 2 positive numbers, out of which 2 into n numbers exist in pairs, whereas the other two numbers occur exactly once and are distinct. It is saying here that there will be n numbers for which pair will exist, and remaining for remaining two numbers pair will not exist. They are going to be two unique numbers, and find the other two numbers return in increasing order. We have to find these two unique numbers and we are going to return them in increasing order. See this example 1. Here 1 is present twice, 2 is also present twice, but 3 is not repeated. 4 also is present only once, it is not repeated. So we are going to return these two values 3 and 4. Output here is 3 and 4. You must have solved a problem, and that problem is previous version of this problem, non-repeating numbers. In that problem, in the given array, only single distinct value is given like this, and we have to find the only unique element present in the array. And the concept of this problem is pretty similar to the concept of this problem, in which only single unique value is present, and in which two unique values are present. First we will understand how we are going to solve this problem in which single unique element is present. So for finding the single unique element, we are going to perform here XOR operations between all the values given to us. Before talking about the result of this XOR operation, let me talk about some of the properties of XOR operations. XOR is a bitwise operator, and bitwise operators work at bit levels. Means if I am doing A XOR B, the result is going to be decided by performing the bitwise operation between each of the pair of corresponding bits from two numbers, and the result of this bitwise XOR depends upon a rule, and that rule says that when the two bits are same, when they are 0 0 and 1 1, from both the numbers they are same, the result is going to be 0 in both the cases when they are same. When they are different, like 0 1 and 1 0, means the bit from the first number is 0 and bit from the second number is 1. Now in this, bit from the first number is 1 and bit from the second number is 0. In both the cases, resultant bit is going to be 1. In this way, bitwise operator works. Now one more property, it is commutative. What does that mean? It means the order doesn't matter when I am doing bitwise operation. Means A XOR B is same as B XOR A. There is no difference. The result is going to be same, and order doesn't matter here. In this problem, if I start doing bitwise XOR operation from starting and from ending, the result is not going to be changed. It will be same for both the cases. And one more property, that A is any number and I am performing bitwise XOR with 0, the result is going to be the number itself. If I am having a number like 3 1 1 0 0 and I am performing bitwise XOR with 0, 0 will have all the bits as 0, and now I am performing bitwise XOR operation. Here the bits are different, so the resultant bit is going to be 1. Bits are different, resultant bit is going to be 1, and here bits are same 0 0, resultant bit will be 0. Here also bits are same, so resultant bit will be 0. So it is 3 and the result is also 3. In this way we'll always get the same number if we perform XOR operation of 0 with any number. Now if I am performing XOR operation between all these values, the 1 XOR 1 will become 0 and 2 XOR 2 will also become 0, and I will left with 0 XOR 3. it is going to give me the result 3. In this way, if I have to find the only unique element present in this array, I will perform bitwise XOR operation between all the values given to me, and I will get the required value. And we are going to use this property to find out the two distinct values in the given array. Now let me take an example. Let me take this example 2 for explaining how I am going to solve this problem. 2 1 3 2. I am going to perform XOR operation between all these given numbers. For performing XOR operations, I am going to write their binary equivalent. Binary equivalent of 2 is 0 0 1 0. Binary equivalent of 1 is 0 0 0 1, and binary equivalent of 3 is 0 0 1 1, and for 2 it is 0 0 1 0. Alright, I am performing here XOR operation, and as we know that 2 is repeated, so XOR of 2 and 2 will become 0, and we will left with only 1 XOR 3. Now what will be the result? 1 XOR 3, it is going to be, here see the first bit from the right hand side for each number, and we can say that 1 is present here even number of times, so it will cancel out, they will make 0 as the resultant bit. So here 0 will come, all the remaining bits are 0 already, and this 1 will make also 0, so I will get result as 0. Now here in the second numbered bit we have 3 ones, odd number of ones, so we will get 1 here. These two ones will make 0, but this only one will make 1 XOR 0, and we'll get 1 as the result. Now here all bits are same as 0, we'll get 0, all bits are 0, we'll get 0. So this is the result 1 XOR 3, and for every case this result is going to be the XOR of two distinct values. And if we find out the rightmost set bit of this result, rightmost set bit, which is this bit, this can be used for finding these two unique values. How? We know that if this bit is 1, only two numbers are going to contribute. All other numbers are in pair, they will make this bit 0, and these two can be different, and only they can make it 1. See, in this case it is 0, it is 1, hence the resultant bit is 0, and all other bits will be in pairs. So this can be used to find these two unique numbers. Now what I am going to do, I am going to create two groups, group 1, group 2. I am going to divide all these numbers given to me in two groups, and according to a rule. And what rule? I will perform bitwise AND operation between all this number and other number, which will be 0 0 1 0. This number will come from this result, XOR result. I will see the rightmost set bit here and its position, and this number will contain only set bit, and its position will be same as the position of this rightmost set bit. All other bits will be 0 here, because we are concerned with this position bit only. Now with this number I am going to perform AND operation with all these number given to me in the array, and for the numbers for which result is 0, so the result is going to be of two type, 0, it can be 0 or it can be 1. If it is 0, first I will perform the bitwise AND with this number 2 and this number. Now let us see the result. It is going to be non-zero. It is going to be non-zero because we are concerned with this bit only. This bit is set in both the numbers, So the resultant bit will be 1. So definitely it is going to be a non-zero number. The result is going to be non-zero. So for the numbers which are going to be non-zero, I am going to send them in group 2. 2 will come here. Alright, it will give me some result non-zero, non-zero, and I will send it to group 2. Now for this one, the result is going to be 0. This bit is 0 here and this bit is 1. 0 bitwise and 1 will give me 0. So I will send all those numbers for which the result is 0. Now this number will also give me a non-zero result because this bit is set. So it will go to group 2. It is in group 1. 1 is in group 1. Now this remaining 2 will also go here. It is 3. This 3. Now this 2 will also go here because this in this the position of this bit will be same as the uh, position of this bit. It is set, it will be set in both the numbers and it will go here. For any other number, they are all in pairs, so they will definitely they will go to a single group. It will not happen that one number is here and other number of the same pair is in other group. So now I am left with only this much problem. I have to find unique numbers in two separate groups, and these two groups are containing only one unique values. Here one unique value is 3, here one unique value is 1, and that we have discussed how to find out the only unique value in the given array. We will perform XOR operation between all of them and we will left with 1 and 3. Now the only question that is remaining here, how we will get this value. How we will get this value? It is pretty simple. We'll get it through a formula of n bitwise AND, then inversion n minus 1, which we have learned in bit manipulations. It says that perform bitwise AND operation of n, any number, it can be any number. Here this will be our result of the XOR of two numbers, and we'll perform AND operation with n minus 1 inverted bits, and it will be this number. Let us see how. Here n is 1 0. It is definitely, it is the decimal binary representation of decimal number 2, and it is 1. 2 minus 1, it is 1, and its binary representation will be 0 0 0 1, and after inversion it will become 1 0 0 0. It will be 1 1. Let me write it again. 1 1 1. After inversion it will become this number 1 1 0. All the 0 bits will become 1 and set bit will become 0. Now I am going to perform bitwise AND operation. 1 1 1 0. It will give me this number which is required. Now we have discussed the approach. Let's code it and see how it works. First we are going to perform XOR operation between values given in the vector. So XOR res initially 0. This variable is going to hold the result of XOR between all the values provided in nums vector. So I will start from 0 till length of nums dot size I plus plus XOR result XOR res is going to be XOR nums i. Now after this we'll find our required value, which is this value, and we are going to use this formula. XOR res will store in the same variable XOR res, and it will be XOR res bitwise and inversion of XOR res minus 1, and with this value we are going to create two groups, int group 1 and int group 2. Now again we are going to traverse the vector nums from 0 till its length I less than nums dot size. If the AND operation between XOR res and bitwise and nums I is going to be a non-zero number, then I will send them in group 2. So it will be group 2 XOR is equals to group nums I, and all other numbers I will send in group 1 XOR is equals to nums I. Now we will be having two different unique values in GP1 and GP group 1 group 2 variable. Now I'm going to return them in increasing order. So I will return first the smallest value. So I will check if GP1 less than GP2, then I will return the vector GP1 then GP2. In other condition GP2 will be smaller, then I will return GP2 first, GP2 then GP1. This is it. This is whole code. Now let's try to run it. Yes, it is working. Now submitting it. Yes, all the test cases are passed successfully. It is working absolutely fine. This is it for this video. Thank you.